Hey everyone, and welcome to this last lecture on conic sections. In this lecture we'll be talking about hyperbola. In the previous lecture we got done with the ellipse, before that with the parabola and the circle. So these four we were going to discuss in the conic sections, and now we're in the last topic of this conic sections, which is the hyperbola. So let's see what is a hyperbola. So just like in the previous lectures that we talked about in the three previous conic sections, we always talked about these conic sections in terms of a plane and in terms of point, rather than the shape of the conic section, because this way it is rather easy to understand these conic sections mathematically, because we are more familiar. We are not discussing shapes over here, we're discussing math over here, so we're more familiar with the graph and all the points on the graph. So, and we're familiar with the plane, so that's why we have done all the conic sections with respect to the points and plane on the graph. So just like that, the hyperbola, this is the definition for hyperbola, and this is what it comes out to be, that this is a set of all points in the plane, the difference of whose distance from two fixed points remains constant. So now we have 2 points on a conic section. Usually you only had 1 point. They were talking about the difference from the foci to be 1 point. Distance of a fixed point to the foci was always 1 point, but now we have 2 points. One is this point and the other is this point. So if the distance from these points to the foci, first of all, forget about this triangle over here, A, B and C. We don't have to discuss this right now. We'll get to this afterwards if we have to. Right now let's just focus on the shape of the hyperbola. So this is the hyperbola. This is actually the hyperbola. This arc over here and this arc over here, this makes a hyperbola, and this is the plane. This whole is the plane, and these are the 2 points that we are talking about. So now let's go and see the equation of the hyperbola. The equation of the hyperbola is this. So this is the generalized equation of the hyperbola, that of the one that we saw above. This is the equation of the hyperbola, in the hyperbola which is centered around the horizontal axis, that is the x-axis, and this is centered around the origin, that is 0, 0. So we have been talking about this for the past 3 shapes, that the concept of h and k, in which the actual equation is h and k, that is every conic section is centered at h, k. And in this case h and k would be 0 because it is centered at 0, 0. So then that equation would come out to be this one. So this is the equation of the hyperbola: x square over a square minus y square over b square is equals to 1. Now what are the properties of this equation? The properties of the equation are these, that they are x and y are squared. This is always equals to 1. A square is always the first denominator. No matter which equation that do you have, a square will be the first denominator. C is an important thing over here. C square is equal to a square plus b square. We talked about this over here. We saw this over here as well. This is c square is equal to a square plus b square. This is simple Pythagoras theorem. And what does the c? What does the c represent? C is the distance from the center to each of the foci on the major axis. So you have this center over here, and c is the distance to that, distance to the center, right? So c is the distance from the center to each foci on the major axis, and a is the distance from the center to each vertex on the major axis. So this is the vertex over here, this is the center, and this is the vertex. So you have this a over here, and if you don't need to find c through this method, but of course we know what y is, we know what a is, we know what b is, so we can find out c through that. So if you want to find out c and a, so basically this distance is a and this distance is c, and this is ac as well, which will be given a negative value of c because it's on the negative side of the x-axis, and this is the value a. And if you want to find out the numerical number over here, that it will come out to be negative a. So moving on, let's now see some other properties of the hyperbola. The major axis has a length of 2a. We are talking about the major axis over here. This is the major axis. So of course this is just common sense, and the length will be 2a. This is a, and this one would be a as well. Of course in the negative side, but the length will become 2a. Eccentricity. Now I talked about eccentricity in the previous lecture about ellipse, but I didn't go into the detail of it. Eccentricity is basically the property of any shape which makes it closer to a circle. The more eccentricity it has, the more circular it would be. So over here, this is the same value, this is the same way to find the eccentricity as it was in the previous conic section as well, in the previous lecture as well, and that is C by A. C, as we know, is the this value over here that we discussed, the distance from the center, which makes the definition of hyperbola, and A, we know, is the point on the plane, is the vertex, is the distance between the vertex and the center. So this eccentricity will be C over A, and the higher it would be, the more chance it would be that the hyperbola is going to be circular. So x square is first, then the hyperbola is horizontal, because we know that the horizontal axis is x axis, and if it is centered around the x axis, that means it would be, the major axis would be x axis, and the x square would be the horizontal the hyperbola would be horizontal, and if y square is first, then the hyperbola is vertical. We'll see both of these examples as we move on. So let's see a horizontal hyperbola. So this is a horizontal hyperbola over here. This has a center at 0, 0, and this has a horizontal axis. As we can see this from the shape, it opens to the right and it opens to the left. So this hyperbola has a major axis of this x-axis, and the equation that represents this hyperbola is x squared by a squared minus y squared by b squared. So this equation, through this equation, we can infer this, that x square means x square is before y square, so that means that this is going to be centered around the x-axis, and that is why this is a horizontal hyperbola, and it has a center at a 0, 0. The vertices are of course going to be a, 0, that is this point over here, the distance from the origin to this point, and origin to this point over here is going to be the vertex. Of course, since it is on the x-axis, the value of y would be 0. It is easier to know that, a, 0. Just like the foci would be this points outside the hyperbola that make the definition of the hyperbola, so f1 and f2. So these points, as we can see over here, are equidistant from this arcs of the hyperbola, and the points once again have the x value but no y value, because they are on the x-axis. Now asymptotes. Now what are asymptotes? Asymptotes are basically these lines that you see passing through the origin, but they do not touch the hyperbola. If they go to infinite, if these straight lines, I'm talking about this line over here, these gray lines over here, these lines are called asymptotes. So basically, if this line goes towards infinity and this hyperbola goes towards infinity, no matter how close they get to each other, they would never join. So this is the line which is an asymptote. So the way to find the equation of this line is, this is the equation of the line: y is equal to plus minus b by a and x. So b and a we would have, so this is the equation of the line. This is the equation of this asymptote that is on the negative side of the x-axis. Forget about the section of the line below the y-axis, and this is the line which is on the positive side of the x-axis. So this you have as the asymptote. Now moving on to the next hyperbola. The next hyperbola, we have this equation for the hyperbola: y square over a square minus x square over b square is equal to 1. What do you think is going to be the shape of this hyperbola? We already discussed what would happen if there is a y before an x, or x before an y. So since this has a value of since the y square is before x square, we know that this is a vertical hyperbola. Vertical hyperbola is a hyperbola which is centered around the vertical axis that opens up and down, and the major axis is the y-axis over here. So as you can see over here, the vertex will be 0, plus minus a, because x, it will be on the y-axis, and the value of x on the y-axis is 0. So the vertex is going to be 0, plus minus a, and the foci is going to be 0, plus minus c. These points represent the foci, this point over here and this point over here, and the foci is the point that makes up the definition of the hyperbola. So you see, as the hyperbola opens up and down, this is the vertical hyperbola, and the asymptotes over here would have a slightly different equation than before. The asymptotes are going to pass from here to here and from here to here. And the previous example that we saw, the asymptotes equation was negative b by a, plus minus negative b by a x. Over here, the asymptotes values are going to be plus minus a by b over x. Of course, as you know, the shape of the hyperbola, the direction of the hyperbola changed, so will the equations connected to it. Now, moving on. This is the actual equation of the hyperbola: x minus h whole square, y minus k whole square, a square, or in b square equals 1. So you see, if a hyperbola, this is how a hyperbola equation really is. It is centered at h comma k. In the previous example that we saw, it was centered at 0 comma 0, so we just put in the values of 0 comma 0 and we got x square minus y square and x square over b a square and y square over b square. But the actual equation of the hyperbola is this. All you have to do is plug in the values and you will get the answers. So if you want to draw a hyperbola, I suggest you draw a hyperbola through this equation. What would happen is that you would get you would understand the concepts better, because now you have actually drawn a hyperbola. So of course, just before we go into what the vertex would be, what the foci would be, I would like you to first take a pen and paper and actually try to write down the equations of those vertex and foci yourself, because we have already discussed that. We've already discussed this. The vertex is going to be 0 comma plus minus a for the vertical one, and a plus minus a comma 0 for the horizontal one, and so goes the foci. Now over here we have h comma k. We know, we have seen from the conic section of the parabola and the ellipse how an h and k make the difference. So why don't you add the same things over here and come up with the equation yourself? If you put in some time, you pause the video and you take some time, like 5 to 10 or even 15 minutes, and you come up with the equation, you're not going to forget it ever, because this way you would have derived the equation yourself. After putting down your knowledge that you have and the concept that you've learned, you have derived a new equation, and that equation, you know, you've already done this so many times. I know you're going to get it right. So why don't you give it a try, and I'll show you over here as well. Pause the video. If you don't want to pause the video, if you just want to see the answer, that's okay as well. So you see, this is the answer, and the same thing has happened again. Now the horizontal hyperbola had the equation of a comma 0 for the vertex, and the foci was going to be c comma 0. Now why was that? Because it was centered 0 comma 0. So now, since it is now centered at h comma k, so the vertex now becomes h plus minus a comma k and h plus minus c comma k. K is going to be the y value over here of the new origin, that is the green dot over here, and the asymptotes are also going to have something different. It's first it was plus minus b over bx over a, now it's k plus minus bx over a minus h. Of course this was inside the brackets. So you see, all of these conic sections are basically following a pattern. That pattern is that first we see a conic section that was centered at 0 comma 0. We see an equation for that, and then we come up with the new conic section. We come up with the new equation for that conic section, which is centered at h comma k. H comma k is actually a non-zero value of the center. First we were just discussing 0 comma 0. Over there we were also discussing h comma k, but the values of h and k were 0. So that didn't come into the equation. There was no point to bringing h and k into the equation. But overall, the thing is that you have a shift over here from the center. The center over here is 0. Instead of 0 comma k, it's plus minus h and k. It could be plus or minus h and k. So you just add the values of that to a and c. So vertex, that is this blue dot over here, that this is going to be h plus minus a. Of course, since it is on the left side, since it is on the left side of the vertex, this is going to be h minus a, and on the right side is going to be h plus k. And the same goes for the center foci, that is c. H minus c is going to be give you this value, and h plus c is going to give you the other value, which will help you find the foci. Now moving on, I think it's pretty obvious what's going to come next. It's the hyperbola, that is a vertical hyperbola that is centered at h comma k. So what will be the equation of that? So let's just see this equation over here. X minus h square. One thing we know is that instead of x minus h square over here, we're going to have y minus k square. because since it is now centered on the vertical axis, so y is going to come first. So y minus h whole square and x minus k h whole, y minus k whole square and x minus h whole square is going to come over here. So the vertical hyperbola, this is the equation for that, just like what we discussed before. So this is y minus k whole square and x minus h whole square is equal to 1. So this is what we have for the answer. This is the vertical hyperbola that is not centered 0, 0, that is centered at a non-zero value. So the same difference. This is going to be h and h, and k's are going to be added to the vertices in the foci, just like we have been discussing before as well. So this is pretty much it for the hyperbola, and this is pretty much it for the conic sections as well. So we are done with the coordinate geometry part 1. We got done with the simple coordinate geometry. Now we have done with the part 2, that is conic sections, and now we would be discussing starting with tomorrow with part 3, and that is 3D geometry. Or I might just end up discussing some other smaller topic for now, so that it doesn't become monotonous. So this was pretty much it. I hope that you've enjoyed this coordinate geometry thus far, and I'll be starting with hopefully with 3D geometry next. Hopefully I'll see you all for those lectures as well. So thank you very much.